Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth. Hello and welcome to Physics with Beth and Beth. I'm Beth. We're in that AP Physics 1, Unit 7, Oscillations. The last video I just posted, we talked about concepts of graphing simple harmonic motion. If you haven't seen that, I highly recommend it. Before we jump in here, I'm just going to tell you in that video, we discovered that velocity is 0 and acceleration is at a max at our amplitude points, meaning the greatest distance that is stretched or compressed. So that would be at A, here, here, and here. And I can even label those A, B, C, D, and E. So at A, C, and E, we're at amplitude points. At B and D, we're at equilibrium. All right, now equilibrium points, our acceleration is 0 and our velocity is at a max. Again, I'm not going to take time to explain this because I've got quite a bit to do, but go back and watch that video if you don't understand that. We're going to talk about the difference between a cosine graph and a sine graph, because on the new equation sheet we have this year, they have a position equation, one for cosine and one for sine. All right, so you're going to need to know the difference. A cosine graph is going to start at the positive amplitude. So this starts, positive is above the equilibrium line, negative position is below the equilibrium line. Here's my equilibrium line, and again, if you don't understand equilibrium line, go check out that video. But cosine graphs are going to start at the positive position at an amplitude. Okay, so this is a cosine graph because we're in the positive position. Here's my position versus time, and I have I'm in above the equilibrium line, which means I'm at positive position. Now, sine graphs are going to start at equilibrium and then move up and then come down. All right, so I'm at equilibrium where x is 0 there at that equilibrium line, and then I'm moving in a positive direction here, and I have one cycle. I move up, come back to equilibrium, move down into the negative position area. This is my positive above the 0 line, and then I end up at equilibrium. So up, down, and back up. That's one cycle. I've shown you two ways, one with it hanging and one vertically and one horizontal. This would be what it looks like for a sine. You're starting at equilibrium, you're moving into positive position because remember positive is to the right of equilibrium and negative position is to the left. We're moving and being stretched, we're going back to equilibrium, we're being compressed, and then we're back to equilibrium. That would be one cycle from equilibrium, positive equilibrium, negative position, and back to equilibrium. So that's how that works. For the cosine graph, we start at a positive amplitude, so we're here compressed, and then equilibrium to negative position, back to positive position, and then back to equilibrium, and then back to positive position. Positive equilibrium, negative equilibrium, positive. And then again, same thing with it horizontal, except I'm starting at a positive position, and not just any positive position, the amplitude, the maximum positive. So positive position, equilibrium, negative position, equilibrium, and positive, because again, to the right is positive, to the left is negative. Okay, we're going to take this graph now that we understand what's happening, and we're going to translate from position versus time to velocity versus time to acceleration versus time. First thing, draw these little lines. It's going to make it much easier with amplitude and equilibrium points to understand and know how to translate this. Okay, we know at A, C, and E that those are amplitude points, maximum stretched or compressed, and our velocity is 0. So I'm going to my amplitudes of A, C, and E, and I'm drawing A on the velocity because this is our 0. It's equilibrium in position, but on the velocity, this is just 0 meters per second at all of my amplitudes. Okay, now I'm looking at my slopes, because if you remember that old junior high equation, rise over run, I have rise is my position on my y-axis, and my run is my time, and oh, we know that, that's velocity. All right, so that means the slope of this curve is velocity. Here I have a negative slope, so it's negative velocity. Here it's negative velocity. Here it's positive velocity. I have a positive slope, and here I have a positive velocity. Now, if you struggle with slopes, think about what the spring is physically doing. It's moving down here. Well, we labeled down as negative velocity. It's still moving down. That's negative velocity. So if you had this here at max compressed at an amplitude, then it's moving down, it's moving down. Now it switches, it's moving up, and it's moving up. That's positive. And it's the same thing if you think horizontally. It's starting at an amplitude and it's going to have negative velocity. So I'm starting at this amplitude of max stretched and I'm moving to the west. I'm moving left. That means that's negative velocity. And then I continue to move to the left. Still negative velocity. Then I start moving to the right, back to equilibrium. Well, that's positive velocity. And then I move even farther to the right to get back to my amplitude. That's positive. So it works in all those ways. So now I know that I am moving negative. So I need to be negative velocity because that was negative. And remember, this is negative, this is positive. Below the zero line is negative. I'm still negative, but I'm going to zero. So here we go. There we went from negative velocity back to zero. Now I'm at positive velocity, and then I'm still at positive velocity, but I'm heading to my zero velocity because at the amplitudes, velocity is zero. And again, if you, I explained that in the earlier video if you need that. So now I'm going to look at this and I'm like, oh, when I said at equilibrium points, my velocity's max. Look, B is in equilibrium, here's my max velocity. D is in equilibrium, here's my max velocity. I have a max positive. If this was, I don't know, we make up a number, 5 meters per second. Then this is at negative 5 meters per second. All right, so that is how you translate a position time to a velocity time. You need to put your 0 points where velocity is 0, which is at amplitude points. Put those on. Understand that the slope is velocity, and if you have a negative slope or a positive, and then draw that out. And it all makes sense. Look at this. We were at 0 velocity, and we hit a max velocity at B. That means we're speeding up. Am I speeding up? Sure. I went from negative 1 meter per second to negative 2 to negative 3 all the way to negative 5, because remember the negative is just direction. And then from B, I've got maximum velocity and I'm coming into the amplitude where velocity is 0. Oh, does that show, does my graph show that? Sure. I went negative 5 meters per second to negative 2 meters per second, back to 0. And again, the same thing here. I'm going from 0 to velocity 0 to a max velocity. And I'm positive, I'm moving up. Does that show that? Sure. 0 meters per second, and I'm speeding up to some 5 meters per second. And then yet again, we're going from maximum velocity to 0. Does that show that? Sure. That's how you translate. Now, acceleration versus time is really just the exact opposite of your position versus time. Now, when you get into mechanics with calculus based, you'll find that this acceleration is actually the second derivative is equal to the second derivative of position with respect to time. So it just means it's going to be the opposite. So if I start high here, I'm going to start in the negative here, all right, and I'm going to flip this. If this goes down and then up, this one is going to go up and then down. So, so what it's going to look like is remember for acceleration is a max at the amplitude points. So I'm going to have a max at A, C, and E. And acceleration is 0 at the equilibrium points. So I'm going to go, here's my equilibrium. I know I'm 0 here. And another equilibrium, I know I'm 0 here. So my acceleration is 0 at the equilibrium, and this is the acceleration versus time graph. Now I'm going to go and back to my old slope formula, and I'm going to go, oh, let's see, rise is velocity on this graph, velocity versus time, run is still time, and oh, that's acceleration. So I'm going to look at the slopes here. I have a negative slope here, that's negative acceleration. I have a positive slope here, I have a positive slope here, and I have a negative slope here. And those are all slopes here are represented on a velocity versus time. The slope is acceleration. So I know I have a negative acceleration, and I know that at my amplitudes, my acceleration is a max. So, and again, watch the video, but I know I'm here. I've got a negative acceleration. That means I need to be below this 0 line for acceleration. So it looks like this. Then I have a positive acceleration in the next part. Okay, well that looks like this, and I back up to my max. And then I know that I have a positive acceleration here, but it's going to 0, and I have a negative acceleration that looks like this. That looks exactly like the opposite of your position time graph. So that's how you can check it. But again, I'm going to go, oh, that was negative acceleration. That's what I'm showing here. I'm below this 0 line. Everything below this 0 line is negative acceleration. Just like everything below the velocity time, that 0 line is negative velocity. So I have negative acceleration, then positive acceleration. I'm above that 0, positive again, but I'm coming to 0 because I know at my amplitude points, at my equilibrium points, my acceleration is 0. So that's why my equilibrium, I put 0, I put little dots here for 0. And it looks exactly opposite. And there you go. Now let's do it really quickly again. I'm not going to go into as much detail on this one. We're just going to do it again, but with a sign. This was cosine. Remember cosine, it's going to start at that positive maximum distance from the equilibrium. That's hard to say. All right, so now I'm starting at the equilibrium line. So I'm going to label my points A, B, C, D, and E again, but watch that. A is an equilibrium now. Over here it was an amplitude, but we're starting in a different spot. So first thing on my velocity time, I know velocity is 0 at all amplitudes. Here's an amplitude, B and D. So I know I'm at 0 here. I know I'm at 0 here. I know that that slope is velocity. That's a positive velocity. That's a negative velocity. That's a negative velocity and a positive velocity, those slopes. All right, so I know that I am starting at a positive velocity up here. And then I go to 0. And then I have a negative velocity. And then I have a positive, so let's go. We have a positive velocity. I'm in my positive section. And then I have negative, so I'm going down. Ooh, that was a straight line. That should have been a curve. All right, somewhat better, maybe not. Then I still have another negative velocity, so that goes up to 0. And then I have a positive velocity to end on. And that's what my graph's going to look like for a velocity time this time. And you're like, but wait, that looks like this position time. Okay, don't think about that. Just take it one graph at a time. All right, my B was my amplitudes, and I know that velocity is 0 at amplitudes. B and D are my amplitudes. I have 2 this time. Here I had 3 amplitudes. That's why there were 3 points. Okay, now I've checked this positive. I am at I'm going to 0 velocity up here. I'm at a max. That shows me slowing down from max to 0, and then I go from 0 back to a max. That's showing the exact. This is absolutely right. You can kind of check it in your head, and it's negative velocity. Perfect. Now we know that that graph's done. That our position time is going to be the opposite of our position time is going to be our acceleration. All right, but instead of going up, we're going down. So at equilibrium lines, we remember that acceleration is 0. So I'm going to put a 0 at this equilibrium point, at C, at that equilibrium point, and at E. So that's where my acceleration is 0 because its acceleration is 0 at equilibrium. And then I'm doing the opposite. If I went up, I went down. And it's going to look like that. It's just the opposite. I had a little half loop here that was up and a half loop that was down, and they're just opposite. Now, can I go back and check that? Sure. Because remember velocity time, I've got a negative acceleration, I'm negative. I still am negative acceleration, still in the negative section of this graph. All right, and then I go up, I have positive acceleration, and I'm in positive. I have another positive acceleration, I'm still positive. These are everything on this side is above this equilibrium. Sorry, let's try that again. Everything above this 0 acceleration line is positive, above it, and then below it is negative. So that's how you translate them. I hope that helps. Thumbs up if you like this video. We would love that. If you subscribe, love that. Share with friends, also love that. But we hope this video helps. Because, and then trust me on this, the more you practice this, the better you'll get. But always label your amplitude points as 0 on your velocity time graphs, and always label your equilibrium points, label them as 0s on your acceleration time graphs. That will help. And then label the positive or negative slopes. So I hope that helps. Thank you for watching, and happy physicsing.